But at some point, we also know that mass can also be related by energy by E is equal to mc square, right? So anything that we learn about is related to either energy or it is related to mass. Okay, so that's one thing. And in this chapter, we are mainly focusing on energy. And one of the other component that is a physical quantity that we have to learn is always is time. Time is also something that is universally a truth. Okay, so mass, energy, and time, and we like study the phenomena which is dealing with mass, energy, and time all the ways. And this is also related to physical chemistry. So in this chapter, we are going to be touching a bit more of physics part. That is, we are going to touch about electricity here. Okay, so when we talk about energy, and if we study energy, we study two things about energy. Whenever we study energy in science, we either study its transfer or we study its transformation or conversion, right? We transfer energy from one body to another, or we transform energy from one form to other. Transformation. Now we have studied this transfer part in the chapter that is known as thermodynamics. The transfer of heat from one flow. We are talking about a flow of energy here, right? This taught in the chapter that is thermodynamics. In transformation, you must have studied this transformation of energy in physics, like if potential energy changes to kinetic energy. Like when I'm dropping a pen, then what is happening? The potential energy is converted to kinetic energy. Similarly, kinetic energy can also be converted to some kind of potential energy. Like if we have water falling down from a dam, that means in that case we can use convert it first of all to the mechanical energy. The turbine is moving, and then further convert the turbine's movement, that energy, mechanical energy, to electrical form of energy. Okay, so some kind of potential energy which we can conserve, it is there. So transformation, and in this chapter we are going to learn about the electrical energy and its exchanges and its transformation with the chemical energy. So we have electrical energy. Now, energy, you get energy whenever something spontaneously happens. So if you have a pen, if you have water that is falling up from a dam, then in that case, what is happening? That water is falling spontaneously, and when it is falling spontaneously, what is going to happen? The turbine is going to move, and then you are going to create some electrical energy. Now, in chemistry, also there are some processes which are spontaneous. Now, if we take that, the falling of water, and we can convert that to electrical energy, then why can't we take the small minute examples of spontaneous reactions in chemistry and then convert it back to electrical energy? So in this, what we are going to learn electrical energy, and there is some chemical energy. Now, chemical energy, we are talking chemical energy in the sense that of reactions. So reactions can happen spontaneously and non-spontaneously. Some reactions, they give us energy, and some reactions, they want energy, exothermic and endothermic. Okay, so when I say chemical energy, then I mean that energy only, which is in the form of heat generally. Chemical energy, okay, chemical energy. Okay, so if we go from here to here, that we are converting chemical energy to electrical energy, and we also will be using electrical energy for some chemical transformation. So this is known as galvanic cell. If I convert chemical energy to electrical energy, and if I use electrical energy for some chemical transformation, then it is known as electrolytic cell. Okay, so these are the things that we are going to learn in this chapter. But before that, let us write some important points. Right, the first point, what is electrochemistry? Electrochemistry is study of production of electricity from energy which is released during a spontaneous chemical reaction. During a spontaneous chemical reaction. and it is the use of electrical energy to bring about non-spontaneous chemical transformation. Okay, so this is electrochemistry. Now, whenever we have spontaneous reactions, this spontaneous reaction, it is going to release energy. And this can be converted to electricity. Okay. Similarly, what we are going to do, we are going to give electricity to a non-spontaneous reaction. Okay, non-spontaneous reaction, and it is going to give me some chemical change. And that means that reaction is going to occur now. Okay, so chemical reaction will happen. Okay, so these are the main themes that we are going to study now. Please write this down. Let me know when you're done, guys. Done? Done
Yes.
or not done? All of you done? So before we start this, what we are going to do, we are going to learn a few things about. We're going to learn a few things about the few important terms, as I say, that you must have stumbled upon in 11th standard, but you may or may not remember that now. Please write some important terms. Number one is the couple that is known as oxidation and reduction. Oxidation is loss of electron. So when I have zinc, so zinc is getting, what is happening from zinc? Zinc has all its electron, and then zinc loses some electron. So we get zinc 2 plus, right? If zinc is going to lose electron, and we are going to get 2 electrons which are away from zinc. Okay, so zinc is not getting 2 electrons, zinc is losing electron. Can all of you see that? Yes or no, please tell me. In this reaction, what is happening? Oxidation is happening. Okay, similarly, if you have reduction is going to be gain of electron. In this, we will have, let us say, for example, CO2 positive, and it eats 2 electron in order to give you copper solid. So this is an example of reduction. Okay, then third is electrolyte. We learned electrolyte in the chapter that is equilibrium acid basis theory. In that we learned electrolyte. What are the electrolyte? Compounds that dissociate and form ions when in liquid phase or aqueous phase. Okay, so please write compounds that dissociate to form ions. Dissociate to form ions when in liquid phase or aqueous phase. If you liquefy it, then also it is going to dissociate, and if you add water, then also it is going to dissociate in aqueous phase. Right, next, the fourth one, electrode. What is electrode? Surface at which oxidation or reduction occurs. Oxidation or reduction occurs. Right, the fifth one, redox reaction. A reaction in which both things happens, oxidation and reduction. So we also call it an oxidation reduction reaction. All of you got it? Yes or no? Please tell me.
Yes.
Okay, fine. Now, see. Now, whatever I'm going to write this down, explain it to you. You don't have to write it down. Okay, please don't write it down. This is just an explanatory thing on how things would, how you would understand and how you would go towards a big. If you have seen electrochemical cell that the teachers make and that the NCERT has, that is a bit, I can say, to do the least. It is a bit scary. Like there are many components, and how did the scientists they got into there, and how this idea for electrochemistry developed. We'll understand that from a very fundamental principle. Okay, so we have two things. We have sodium and we have, let us say, half Cl2. Okay, so half Cl2, that means you have one chlorine atom. And we know what happens here is, you have sodium, it gives an electron to chlorine. And what happens? This sodium, it becomes Na positive, and this chlorine, it becomes Cl negative. I hope all of you are acquainted with this idea. Yes or no, please tell me.
Yes.
Yes, all of you?
Yes.
Okay, fine. Now, let us suppose, let's think in this way. Suppose we have sodium here and we have chlorine here. That means they are not in contact. What if we have this sodium and this chlorine and we tie them with a wire? So can you see that there can be a transfer of electron through this wire? Yes or no? That will be spontaneous because NaCl is going to, when sodium and chlorine are there, they react spontaneously and they form NaCl. Can you see that the electron can travel through this wire? Yes or no? If I join the sodium and chlorine, right? Now, this is something that we can make use of. Okay, so people thought that, okay, fine, we can use this. We can have this, sorry, and we can use it to light up a bulb, maybe. But once this electron has transferred, that means the light will blink once and then it will turn off. Okay, so we are just imagining things right now. Okay, it will not happen actually like this, but I think you can imagine something like this, like in a very ideal situation. If we can join sodium and chlorine and there can be electron transfers, then we can think that the bulb will light up, but it will light up for once, right? Yes or no? Hanifa Rifatanzan, correct? Now, so we need something which is cyclic. That means which is going on and on and on, at least for a while, not on and on and on forever, but at least for a while, there should be some type of that reaction. So it should be a bit slow, and it should also, so what we can do is we can have we can have one sodium atom and then stack another sodium atom, then again stack another chlorine atom here like this. Okay, so we can do that, but they came up with another method. And they said that, okay, fine, what we can say is that, let us do something like this. Let us take maybe sodium here. Okay, and we will dip something here. We'll have a solution and we'll dip some metal here, and we will dip another metal here. Okay, so please see that we have first of all taken a metal and a non-metal, but now we are taking two metals. And people saw that when you have a solution of, let us suppose here we have CuSO4 and you dip here zinc metal, then we see that in this solution, slowly what happens, this zinc, it starts to disintegrate and it starts reacting, and we get a reaction something. And at last we get a solution in which we have zinc SO4. So we can say that what is happening here, we have CuSO4 and I added zinc metal to it and it got converted to ZnSO4. And the copper, it deposited onto this particular rod that we had here, the copper deposit. So we got copper here. Okay, so here you can see that the metal are playing a good role. So they started with reactions with metal. So we have zinc and CuSO4 and it is giving me ZnSO4 and copper. That means here zinc is in the form of zinc and here copper is in the form of Cu2 plus. And then it is going to get formed. Here zinc is in the form of Zn2 plus and copper is in the form of copper. So that, okay, fine. We can have this kind of couple in which we have the solutions of zinc SO4. We'll have here ZnSO4 and we will have here CuSO4. We'll have here zinc rod and we will have here a copper rod. Have here zinc rod and we'll have a copper rod. Now, when zinc will be dipped in its own solution, then what is going to happen? This kind of equilibrium will be there. Zinc and Zn2 plus, they will be talking with each other. Zinc will be getting converted to zinc Zn2 plus, Zn2 plus will be getting converted to zinc. Nothing more will happen here. Same thing will happen here. Thus, copper is getting converted to Cu2 plus, and the Cu2 plus is getting converted to copper. But as soon as you join these two wires, okay, now what is going to happen when this zinc is getting converted to Zn2 plus? Yes or no? Or if you got that, zinc is getting converted to Zn2 plus. Now, when the zinc from this rod, it is getting converted to Zn2 plus, where are the electrons going? It will have some electrons also, right? It will give out 2 electrons when zinc is getting converted to Zn2 plus. Now, these 2 electrons, they have now a mode of communication. They can travel here like this. So we have got some electrons from the zinc compartment. Okay, so we have got electrons from the zinc compartment. So we have electrons from the zinc compartment and it has traveled towards the copper compartment. Now in copper compartment, it will meet 3 people. It will meet the copper rod. It will meet the Cu2 plus from the solution. And it will also meet the SO4 2 negative from the solution. Yes or no? Please tell me, guys. Can you see this happening?
Yes.
Yes, Rifat, Hanifa, can you see this happening?
Yes.
Yes, okay, fine. Now tell me, this electron, these 2 electrons, it will be eaten by what? The copper rod or the Cu2 plus or the SO4 2 negative? Like if I talk initially, then I can cross this SO4 2 negative because it is 2 negative. That means it is negatively charged. Negatively charged and negatively charged, they will repel each other, right? So obviously SO4 2 negative is not going to eat this 2 electrons. And then let us see copper. What will happen to copper? Will copper eat? Then the copper will say, no, I can't because I am a, what am I? I'm a metal. Okay, so what is the tendency of metal? Metal's tendency is to lose electrons. I cannot eat up electrons, copper in its neutral form at least. I cannot eat up electrons because my tendency is to lose electron. I cannot gain electron. So I have to eliminate this possibility also. Now there is only one thing which can react and which can eat up, that is Cu2 positive. So Cu2 positive, it will react with 2 electrons and it will form the copper ion. Now, the same thing will happen. So things that you are going to see here is, see what is happening. Zinc is getting converted to Zn2 plus. That is fine. That's good. Zinc is getting converted to Zn2 plus. That means zinc from the rod, it is getting deposited in the solution. Zinc is going away from the rod. That means the mass of this zinc is going to decrease. What did they observe? They observed that this mass here, mass of the zinc rod, it is going to decrease because zinc is always getting converted to Zn2 plus and 2 negative electrons. And these 2 negative electrons are going away and it is reacting with copper rather than zinc. It is reacting with copper rather than zinc because it has a tendency. Now, this is a spontaneous reaction. Whenever there will be, like there is zinc and there is copper, then it will be eaten up by copper. Okay. Now, what we saw first thing, we saw that the mass of this zinc rod is decreasing slowly. And since zinc is getting converted to Zn2 plus, the concentration of Zn2 plus is, here what is happening? The Zn2 plus concentration is increasing. This is the two things from the in the zinc compartment. When I go to the copper compartment, I can see that the two electrons, it is getting eaten by Cu2 positive and it is forming copper. That means, please can you tell me what is happening to the mass here? Mass of copper is increasing or decreasing? Tell me. The copper 2 plus from this solution, it is eating the 2 electron and it is getting deposited as copper. So mass will increase or decrease of this rod?
So decrease.
Decrease.
In what? Sorry?
Sorry, it will increase.
Increase, right? Because see what is forming. What is forming, guys? Here,
Copper.
copper is forming. Okay. So copper 2 plus in the solution. There are two things, please remember. Okay. We have this copper 2 plus in the solution and then we have the copper rod. So copper 2 plus from the solution, it is reacting with the 2 electron that is present in the rod and it is getting deposited on the rod. So if it is getting deposited on the rod, that means it is getting stuck on the rod. That means mass is going to increase here. And what will happen to the Cu2 positives? Its concentration will increase or decrease because it is reacted, because it is reacting with two negative and it is getting converted to copper. So the concentration of Cu2 positive will increase or decrease?
So it will decrease.
The copper 2 plus will decrease. Got it? Yes or no? Please tell me, all of you.
Yes.
Okay. Oh, fine. Now, if you see here, the zinc 2 positive is increasing. Okay, the zinc 2 positive is increasing. That means we are increasing the positive charge here, right? And here what is happening? The copper 2 plus is decreasing. If the copper 2 plus is decreasing, but the SO4 2 negative is as it is, right? So we can say that we are getting this part as negatively charged. Yes or no? Can I say that? If positive charge is decreasing, that means negative will be increasing. Yes or no, guys?
Yes.
Right. Now, after a while, what happened? They started this reaction, and this reaction went fine, very fine that the electrons are moving. Now, next observation that they saw was the electron was moving from the zinc compartment towards the copper compartment. And let us put up a bulb also here. But the bulb lit up for a while, but after a while, it again got down. So what is the reason? Why is that happening? As you can see very clearly, that here the electrons are moving this way. Right? The electrons are moving this way. Electrons are moving this way, but this will not go on very long because this compartment here, that is the copper compartment, it is turning what charge? Tell me. The copper compartment is turning negative or positive? Negative, right? An electron is having what charge?
Negative.
Electron negative. So what is going to happen? Will the electron, will it want to come towards this copper compartment or it want to be in the zinc compartment itself because it is positively charged? If the electron will like to be in the electron will like to be in the zinc compartment or the copper compartment after we have got a negative charge here, the
Zinc.
copper compartment, right? Because it is positively charged, the zinc compartment will not let this electron to go towards the copper compartment after a while. Now they have to tackle with this problem. So they came up and they said that, okay, fine. So this is happening because we are having some kind of charges. Okay, the system here, what we have, it is not, the compartments are electrically not neutral, they are charged. So if we got them neutral, if we got these compartments neutral, then it is going to be fine. We are going to work with the cell now. And the cell is going to work for a longer time. So they said that, okay, fine. In order to get a electrical neutrality, we will add a bridge type of thing here. Okay, and in this bridge, we will fill something such as Cl negative and K positive. That means basically we are adding KCl. Okay, now what is going to happen? As the zinc 2 positives concentration will increase, this Cl negative, because it is negatively charged, it will come from this solution and it will go here and it will neutralize the zinc 2 positive. Similarly, if the SO4 2 negatives charge increases and the negative charge is increasing here, the K will travel and it will travel towards the copper compartment and it will get it electrically neutral, and then we can have electricity for a bit more longer time. The reaction will go on until and unless all the zinc has been like all the zinc rod got deposited. I mean, it got converted to Zn2 positive. Till that time, the reaction can go on. It will not go on forever. It is limited to what amount of acids we have. We have how much of zinc and how much of copper rods we have. Okay, so it will depend on that. But if I want to try once again and I want to rephrase all of these things, then we can say that we started with an electron which is going from the zinc compartment towards the copper compartment. In the copper compartment, it meets 3 people, but it can get only eaten by Cu2 positive because it is positively charged. SO4 2 negative has negative charge. That means it will repel the electron. Copper will say that I am a metal. I have a tendency to lose electron, not to gain electron. So it will not eat it. Now, so the electron will travel. We'll have the light bulb which is glowing, but after a while it will stop. Then we will see, we will analyze why it is stopping. We see that the Zn2 positive, the zinc compartment, it is getting positively charged. The copper compartment, it is getting negatively charged. And that is why when the electron is trying to move away from the zinc compartment towards the copper compartment is repelling it, and the zinc compartment is attracting it. That is why the electrons cannot move. And if the electrons are not moving, then the electricity will not be there. So we came up with another solution that we added a bridge type of thing. In that bridge, we have a KCl solution. And what is going to happen? Why it is helping us? It will help when the zinc compartment will get positively charged, the Cl negative will run. It will get it neutral. When the copper compartment will get negatively charged, then the K plus will move towards that compartment and get it neutral. And now we have a well working set of things. So now what you are going to write is electrochemical cell. I hope you understand the working now to a bit. Let us write it more and you will understand more. Okay. Zad, Hanifa, and Rifat.
Yes.
Okay. So please write electrochemical cell. Okay. Electrochemical cell. Electrochemical cell is the cell in which we are going to transfer the chemical energy to electrical energy. Okay. So please write here a cell in which the cell in which spontaneous redox reaction occurs due to which chemical energy is converted to electrical energy is called electrochemical cell. Okay.
Yes.
Now we'll make this, whatever we have made it here. I will copy this, but I have to rearrange many things. Just a second. Let me borrow a photo from your NCERT textbook. Okay, let's leave this actually. Okay, you can write here that here we have here we have ZnSO4 and here we have CuSO4. Sorry. Done, guys? Yes, tell me.
Yes.
Hanifa and Refer done.
One minute, sir.
Okay. So this flow, this big arrow, this is the flow of electron. Okay, this way, and the current is going to move in the opposite direction.
Done.
Done. Okay. So basically here we have two compartments, the zinc compartment and the copper compartment. So if I look at zinc compartment, what is happening right here at zinc compartment? Okay, so at zinc compartment, we can see that a reaction like this is happening. Zinc is getting converted to Zn2 positive plus 2 electron. And can you tell me, guys, what is this? There is a loss of electron from zinc. Zinc is losing electron. Yes or no?
Yes.
So this is oxidation, right? So this is oxidation. So one more thing, wait a second. Now, when we have zinc, this zinc is on the rod. Then this zinc gets converted to Zn2 plus. It goes to the solution, and then this rod is going. This 2 electron is going to be on the rod. Okay, 2 electron is going to be on the rod. Okay, that means first of all it is oxidation. And the second point is that if the electron is in the rod, that means its polarity will be negative, right? Polarity is negative. Because in the rod, what do we have? We have electrons, and electrons are going to get its polarity negative. That is why you can see this here. We have here small negative charge. This guy. This is talking about the polarity of the rod. Got it? Okay.
Yes.
Now, since we are having oxidation here, that means this part of the compartment will be known as the anode. Okay. So oxidation is taking place here. This is the anode. Wherever you have oxidation, that is going to be your anode. Now, if I look at the copper compartment, now please try to write things about the copper compartment. In copper compartment, we are having a reaction like this. Copper 2 plus is eating the 2 electrons, if you remember, and it is getting converted to copper, right? It is getting converted to copper. So this Cu2 plus, it is coming from solution. This is going to solution, by the way. Okay, this is coming from solution, and this is getting from the rod. Okay, and this copper is getting to the rod. Got it? Yes or no?
Yes.
Okay. Now, what is happening here? Here we are seeing reduction. And what will be the polarity here? See, this particular rod here, this particular rod, it is attracting the electron. That means it should be obviously positively charged. Okay, the polarity should be positive right here. Also, this 2 electrons, these are coming on the rod and it is getting eaten by copper 2 plus. That is why also it is positive, you can say. And wherever reduction happens, it is going to be cathode. Got it? Yes or no? Tell me.
Yes.
Yes.
Okay, now since we started with copper compartment and zinc compartment, we are taking this as an example. But what we are now we are going to remove this as the anode. Okay, this is the anode side, and this is the cathode side. Okay, So now what we are going to, we are not always going to look at the compartments. We are going to say what is happening at anode, what is happening at cathode. Okay. Now anode will be wherever oxidation takes place. Please don't relate anode and negative charge. Okay. The polarity. We will talk about polarity after seeing what are the reaction is going to happen, what the reaction is happening. Okay. But we will always relate oxidation to anode. We will always relate oxidation to it. Now we'll write the cell reaction. Now, whenever you have to write the cell reaction, you write the reaction at anode, the reaction at cathode, and you will add them up. So in anode, we saw that zinc is getting converted to zinc 2 positive and 2 electron. Copper in cathode, what is happening? Cu2 positive is getting 2 electrons from the rod. It is getting converted to copper. If I look at the complete reaction, I will add them. Now, while adding, I hope you remember that we can cancel these 2 electrons. Yes or no? Okay. And here we are going to get zinc 2 positive plus copper. Write some remarks. As you can see in here, oxidation is taking place at anode and the reduction is taking place at some different compartment. So it is not a direct redox reaction, it is an indirect redox reaction. So please write an indirect redox reaction. Takes place in electrochemical cell. Okay. So what is indirect redox reaction? The redox reaction in which oxidation occurs. Oxidation and reduction, they both occur in different compartments or different containers. It is known as indirect. You can write this also. Right here, the redox reaction. In which oxidation and reduction occurs in different containers. Occurs in different containers. It's called indirect redox reaction. Right, next. When metal is dipped, in solution of its own ion, solution is dipped in the solution of its own ion, then the metal rod acquires either positive or negative charge with respect to solution. Due to the following reason. Okay. So some metals, they have a tendency to lose electron at room temperature, Mn positive, and it gives n electrons. Okay, so this is the rod, as we saw in the case of zinc, and this goes to solution, and this goes to rod. If we have something like this, then the rod is going to acquire a negative charge, right? So this is known as the tendency of metal atom to get converted into ion. Okay, and then we have the next case in which we have Mn positive plus some n electron. So Mn positive will be from solution, and this will be from rod. It will get converted to metal. So some metal have a tendency to, some metal ion, they have a tendency to get converted to metal atom. Okay. So this leads to negative charge on rod, and this leads to positive charge on rod. Done?
Yes.
Okay. Now let us write the observation that we talked about right here. Observation made for electrochemical cell. Okay, so first thing is that we saw in zinc what happened, the mass of zinc decreased. So rather than writing the mass of zinc rod decreases, what we will write? We will write that the mass at which, and the mass of anodic rod, it decreases. So right, mass of anodic rod decreases. Concentration of metal ion at anode increases. Mass of cathodic rod increases. Concentration of metal ion at cathode decreases. And last point, we'll write that what we saw, that flow of electrons is taking place from the zinc rod towards the copper rod, from the anode to the cathode. Okay, so electrons flow from anode to cathode. Done out here? Yes or no? Please tell me.
Yes.
Okay. Right, next, representation of cell. Right, next, representation of cell. Or cell representation. This is very important. You have to know this quite clearly. And it is also very easy. Okay, you don't have to worry about it. That's going to be very hard. Cell representation is very small thing. You just write A, B, and then you write C. A means anode. Okay, A means anode, B means bridge, and C means cathode. So how it is going to look. For example, if we have that zinc and copper couple. So when we have when a redox reaction, it takes place between two different species, we say that those species are couple. Okay, so as you can see this in this reaction, zinc and copper are a couple. Okay, so zinc and copper, they are taking place in they are taking part in a redox reaction, that means these are a couple. Okay, so zinc copper couple, if we take, then we are going to write for anode. It will be written something like this. See, we have zinc. It was getting converted to, and sometimes you will see everything solid. It was getting converted to zinc 2 positive, which was in aqueous phase. And then we show the bridge something like this. Okay, so this is a symbol for bridge. And in cathode, we saw that we had Cu2 plus in aqueous state. It was getting converted to, sorry, copper solid, not zinc, my bad. Can you see that this is something that was happening in anode? This is something that was happening in cathode. We have just written it in a bit small form. Got it? Yes or no? Please tell me.
Yes.
Okay, and this is a representation of salt bridge. Done all of you? Yes or no? Please tell me.
Yes.
Okay. Now, let us talk about this part where we said that some metal, they have a tendency to get in its ion, and some of the metal have a tendency to get into its the atomic form or the metal form. Okay, that is known as the electrode potential. What is the potential of the electron? Whether it is going to get, whether it is more favorable towards the reduction or more favorable towards the oxidation half. Okay, so when we talk about electrode potential, so we are talking that what this particular metal is going to do, whether it is going to lose electron or it is going to gain electron. And whenever we say gain electron, so metal do not gain electron, they will gain electron in its ionic form. So write the next topic, that is electrode potential. Please write electrode potential. Okay, okay. The potential difference between metal rod and surrounding electrolyte and surrounding electrolyte is called electrode potential. Okay, now we can have a solution like this, and we can dip a metal. Okay, and this can be measured at various. Now this particular solution, it will have some type of concentration, and according to the concentration, if we have a very high concentration, then this metal this metal rod, it will not get converted to ions easily, because we already have a lot of ions in the solution. So it will depend on the concentration also, it will depend on the temperature also. So these things, and it will depend on the pressure also. So these things, they determine, they affect the electrode potential. So we have to have some kind of standardization. So we standardize this electrode potential, and you write the first point in remark. The first point is, right, if electrode potential of metal rod, if electrode potential of metal rod is calculated at 1 atmospheric pressure, 25 degrees Celsius temperature, and 1 molar concentration, of electrolyte, 1 molar concentration of electrolyte, then it is known as standard electrode potential. Then it is known as standard electrode potential. All of you got this? Yes, no, please tell me.
Yes.
Okay, now let us try to understand this actually. What is this electrode potential? When we have this solution, and we are only talking about the standard electrode potential now, okay? Once you have standardized it. And when we dip a metal, now one of the two things can happen, right? Either the metal N positive, it will take electrons and it will get converted to metal, or what is going to happen? The metal, it will get converted to Mn positive, it will go into its this solution and it is going to give out electrons, N electrons, not 2 electrons, rather N electrons. Okay, now in this case, what is going to happen? This is going to get a positive potential with respect to the solution. In this case, it is going to get positive. This is polarity is going to get positive. And in the second case, it is going to get some negative charge. Now, wherever there will be a difference in charge, there will be some kind of potential developed, and that is known as the standard electrode potential. But can you see that we are having some kind of trouble? We are having some kind of trouble. Let us suppose let us suppose that this is happening spontaneously. Okay, what is happening? This is happening. So what is this, oxidation or reduction? Tell me, guys. What is this? Loss of electron, or is this gain of electron? What is the metal doing? Metal is losing electron or it is gaining electron? Look carefully and tell me.
So losing.
Losing. Very good. So it is losing electron. That means it is oxidation. Okay. What is happening? Oxidation. Metal did not have. See what is happening here. लोग को ऐसा लगता है यहाँ पे metal को तो मिल रहा है ना? No. Don't please. Okay. ऐसे नहीं. Electron is away from metal ना. Metal electrons are separated. That means it has lost the electron. It has lost the electron. Okay. And the arrow is pointing this direction. अगर ये उल्टा होता ना इस तरह से, तब हम बोलते हैं यहाँ पे कि गेन कर रहा है इलेक्ट्रॉन, कि मेटल को मिला इलेक्ट्रॉन और फिर इधर चला आया, ठीक है. लेकिन इट इज नॉट हैपनिंग लाइक दैट. वी आर हैविंग इन दिस वे. द मेटल इज गेटिंग सेपरेटेड फ्रॉम द इलेक्ट्रॉन. इट इज ऑक्सीडेशन. नाउ दिस पर्टिकुलर will give me some potential and it will be known as standard oxidation potential. Yes or no? Is that right? Yes or no? Please tell me.
Yes.
Okay, it will be known as standard electrode potential. Fine. Now, this standard electrode potential, it will be measured in terms of volts. Potential will be measured in terms of volts, and it will be measured in terms of volt. And if this particular reaction is spontaneous, then we are going to get electricity. Yes or no? Please tell me, guys. Correct? If this reaction is spontaneous, we are going to get electricity. And if we are going to get electricity, that means we are going to get some volts of electricity. That is, say जैसे हमको 5 वोल्ट मिला या फिर 6 वोल्ट मिला, इलेक्ट्रिसिटी मिला, ठीक है. अब हम उसका जस्ट अपोजिट केस देखते हैं. मान लेते हैं आपके पास ये रिएक्शन नहीं हो रहा है अपने आप. ओके, तो दिस रिएक्शन इज नॉट हैपनिंग. दिस रिएक्शन इज नॉट हैपनिंग. अच्छा, इसी का हम केस देखते हैं, ठीक है ना. अच्छा, एक बात आप बताइए आप लोग, इफ दिस इज स्पॉन्टेनियस, दिस इज व्हाट? स्पॉन्टेनियस. तो इसका उल्टा तो स्पॉन्टेनियस नहीं होगा, राइट? The opposite of this will not be spontaneous. It will be non-spontaneous. Correct?
Yes.
This reaction. So this is what? This is a reduction. Okay, and this is spontaneous, and then that is why we are getting. See, the voltage is related to spontaneous. It is not related to oxidation. अगर reduction of spontaneous होता तो यहाँ reduction से हम लोगों को voltage of electricity मिलती. But we are getting the electricity from the spontaneous reaction, and it is right now we are supposing it is oxidation. Oxidation and this volts of electricity that we are getting electricity, it has no relation. It is spontaneous. That is why we are getting electricity. Is that clear? Yes or no? Please tell me.
Yes.
Okay. In general, please understand कीजिए इसको, ठीक है. In general, we have taken a case in which oxidation is spontaneous. Okay, that is why it will seem like oxidation is giving me electricity, but it's not the case. The important thing here is the spontaneity of this reaction is giving me electricity. Now here we have reduction. It is non-spontaneous. It is non-spon. And that means it will require energy. Yes or no? Please tell me. Correct? In order for this to happen, it will require energy. Yes or no,
Yes.
guys? Hanif and Rifat?
Yes.
We have to give some kind of energy. So we are giving some electrical energy here. So we are going to give some electricity to this particular reaction in order to happen. Acha, if it is requiring electricity, who will give electricity? Humans will give, na? Yes or no? Humans will give electricity. Ayana.
Yes.
Right? Humans are going to give electricity. Now, if humans are giving electricity, तो हमारा तो खत्म हो रहा है ना? तो हम इसमें क्या बोलते हैं? अगर आपके पास नॉन स्पॉन्टेनियस रिएक्शन है, then you will be giving volts. और आप जब आप दे रहे हैं किसी को तो आप नेगेटिव में चले जा रहे हैं ना, आपका तो खत्म हो रहा है. So you will get some -5 volts और -6 volts. बात समझ में आई आपको? नॉन स्पॉन्टेनियस का रिलेशन किससे है? नेगेटिव वोल्टेज से है. ओके, एंड द स्पॉन्टेनियस रिएक्शन दे हैव अ रिलेशनशिप विद पॉजिटिव वोल्टेज. इज दैट क्लियर? यस और नो? प्लीज टेल मी गाइस.
Yes.
Also one more thing, एक और चीज आप बताइए. Let us suppose we have this particular pen in your table and you lifted it up. Okay, so what did you did? You lifted this up. So you have to work against gravity. Yes or no? Please tell me guys. If you lift something up,
Yes.
right? Now, once you're working against gravity, that means you are putting in energy. And once it has reached this potential energy, it has achieved some height and you drop it. So the amount of kinetic energy that will be released, it will be equal to the energy that you have put in, right? Yes or no? To lift it up, correct?
Yes.
Yes.
Okay. Now, that me tell you one thing, that if we have standard oxidation potential that is equal to plus x volts, then standard reduction potential will be equal to minus x volts. Yes or no? Because ये दोनों तो एक दूसरे के opposite है. Got it, guys? Yes or no? Please tell me.
Yes.
Yes.
This will be for same metal. Right? Metal को मत change कर दीजिएगा. For same metal. All of you got this? Yes or no? Please tell me, guys. समझ में आ रहा है?
Yes.
ठीक है. अच्छा, अब एक बात बताइए आप. एक दूसरी चीज जो आयुपैक ने की है, और इसको अक्सर लोग बोलते थे कि भाई आयुपैक कन्वेंशन हमने ये किया है, बट देयर इज अ रीजन फॉर दैट, है ना? वो रीजन का हम लोग देखते हैं. जैसे मान लीजिए आपके पास है कॉपर प्लस हो आपके पास, या फिर आपके पास हो कॉपर 2+. both will get converted and it will get converted. If it eats electron, it will eat electron and it will get converted to copper. This also will eat 2 electron and it will get converted to copper. Yes or no? Correct hai?
Yes.
Right? Now, if you have been given copper plus and if you have been given copper 2+, you can expect what is the product. It is going to be a metal atom. Yes or no?
Yes.
Correct, guys? Even if you have, let us say, for example, you have CuCl, or here you have something, let us say CuSO4. So in CuCl, you have Cu1 positive charge, and CuSO4, you have Cu2 positive charge. Now, whatever, I mean, even if you are taking a Cu positive or Cu2 positive, it is going to end up to Cu. Yes or no? Correct? Right?
Yes.
But the opposite is not true. If you're starting with copper, I cannot predict that whether I am going to do a reaction in which I am going to get copper plus or I am going to get copper 2+. Correct? Yes or no?
Yes.
Now, can you see that here we are doing oxidation, in which I cannot predict what is going to happen actually, you know, what is the system. But if we are looking at reduction reactions, then we can easily predict what is going to be the reaction. Yes or no? If you are looking at reduction, if you have copper plus, so when if there is reduction, then you know the product. But if there is oxidation taking place, if I just said that oxidation is taking place, then you must know the number of electrons, then only you can predict what is the product. You must know how much electron is getting away from copper. If it is 1 electron, then you will get copper plus. If it is 2 electron, then you are going to get copper 2+. But if you have copper positive, or if you have copper 2 positive, both of these things will get converted to copper only. It cannot get converted to anything else because it has to get converted to its own metal, and that is going to be copper. And here what is happening? Here reduction is happening, and that is why IUPAC said that our SRP will be the standard electrode potential, because electrode potential can be both of these things. It can be oxidation potential or it can be reduction potential. But in oxidation potential, we have a problem that we cannot predict the product. In reduction potential, we already know the product, and we can expect and we can calculate the number of electrons that are being used. So they said that the standard reduction potential is going to be the standard electrode potential. You will write that next point. Okay. All of you understood this thought, you will understand it. If you did not understand it now, slowly you will understand why we have taken standard reduction potential as the standard electrode potential. Okay, so please write here in IUPAC system, or according to IUPAC, according to IUPAC, standard reduction potential is regarded as standard electrode potential. Got it? Yes or no? Please tell me.
Yes.
Okay. Next point you will write electrode potential, or rather, standard electrode potential that is written as E naught. Okay, standard electrode is intensive property. Okay, that means it is mass independent. Right, next point. Standard electrode potential E naught is independent of shape, size, and mass of that electrode. Okay, right, next. E naught of any reaction is unchanged. देखिए सबसे पहले E naught किसी रिएक्शन का तो होता नहीं है ना. Okay, it is E naught of any reaction is unchanged if the reaction gets multiplied or divided by any coefficient. Okay, so for example, if we have Cu2 positive plus 2 electron is giving me copper, and the E naught of this reaction is found to be 0.34. Okay, that means you can see that this is a spontaneous reaction, copper, because we have positive volts of energy. But even if I do something like this, half Cu2 positive plus 1 electron, it's giving me half copper. This E naught is not going to change. Okay, so this E naught is going to be still 0.34 volts. Okay, because it has been measured at a particular condition. That is, we have 1 molar concentration of the solution, and we have 25 degrees Celsius and 180. So it has nothing to do with this particular specific case of reaction. It has already been measured. Even if you have multiplied something like this, 2 Cu2 positive plus, let us say, 4 electron, it is going to give me 2 copper. Here also the E naught is not going to change. It will be equal to 0.34 volts. And let us suppose we have Ag positive plus some electron, which is going to give me Ag, whose E naught is 0.80 volts. And if you have, let us say, 2 Ag plus 2 electron is going to give you 2 Ag. And here also the E naught is going to be 0.80 volt. It is not going to change. Got it? Yes or no? Please tell me.
Yes.
Okay. So let us do some questions now. In this question, what I will show you how to represent some of the cell reaction as galvanic cell. Okay, so if they say represent the following, put it, represent the galvanic cell in which the following reaction happens. Represent the galvanic cell. Galvanic cell is electrochemical cell. Okay, galvanic cell. Representation आपको करना जो याद होगा ABC. Represent the galvanic cell in which following reaction occurs. So for example, the first one I'm taking the simple case in which we are having the same thing. Zinc 2 plus zinc आपके पास neutral, zinc plus copper 2 plus is getting converted to zinc 2 positive and copper. Okay, so first of all, what you are going to do, you're going to identify where is oxidation happening, where is reduction. So what is this? Tell me, oxidation or reduction? What is this? Zinc to zinc 2 positive is oxidation or reduction? Tell me, guys.
So, oxidation.
Very good. Oxidation, na? See, oxidation state is increasing. 0 था यहाँ पे 2 positive हो गया, है ना? So it is oxidation. So here we are having oxidation. That means it is going to be anode, है ना? And this is what? अब तो कुछ और बचा नहीं. यहाँ पे क्या हो रहा है? Reduction हो रहा है, right? So we'll write ABC. As oxidation means anode and reduction means cathode. So in anode, what is happening? Zinc is getting converted to zinc 2 positive. So you'll just write zinc getting converted to zinc 2 positive. The bridge will be like this. Okay, you don't have to write always ABC. Okay, just to tell you guys, we have this mnemonic or trick to remember this. Okay, zinc is going to be Zn2 positive, and in cathode Cu2 positive to Cu. So you write Cu2 positive here and then Cu here. Please understand this thing. Okay, why we are writing Zn here and then Zn2 positive here? Why we are writing Cu2 positive here and not Cu? Why rather we are writing Cu here? This is talking about the products and reactant. And if you have got this cell, ना, आप इस cell से क्या कर सकते हैं? Reaction भी लिख सकते हैं, cell reaction भी लिख सकते हैं. Yes or no? चलिए, please write this one. Then I will give you some more problems. Write all of these things. Okay, ऐसे oxidation हो रहा है, ऐसे reduction हो रहा है ना? And you can also write something like this. आप कुछ इस तरह से लिख सकते हैं. Oxidation or anode is here, and we have reduction or cathode here. We have reduction or cathode here. Okay. So, can I give you some questions now?
Yes.
Okay. Right, for this one, we have nickel solid. Just a second. Let me think about it. Okay. Right. So we have nickel solid plus 2 Ag positive. This is getting converted to nickel 2 positive and Ag solid. Okay. So what is happening here to nickel and what is happening to Ag? Those are the important things that you have to recognize. Once you're done, you will send the answers to me on WhatsApp. If you need any help, you can ask me. Okay. But I need these things. What you have to fill here at least. Okay. I need that. आप अगर represent नहीं कर पा रहे, that is fine. That is not a bigger issue. The bigger issue is that you have to fill these parts. Okay. At least. Okay. Rifat. Yeah, very good, very good. Correct, Rifat. Hanifa. Okay, Hanifa, you have sent it for the first one. I think that is fine. Very good. ठीक है, आसान है, right? What about Zad? Zad, are you sending?
So just a minute.
Yeah. No, Zad, I have not received yet. नहीं, हनीफा for the second one आप क्यों बोल रहे हो वहां पे रिडक्शन हो रहा है? हनीफा, आप can you please turn the mic on? Hanifa, you there? Yes. How do you identify whether something is oxidizing or it is reducing, getting reduced? Tell me. What do you see? What do you look at?
The loss of electron.
Sorry, whether it is
Loss of electrons.
loss of electron. Okay, fine. So let us start here. So we have here copper, and it is getting converted to Cu2 positive. So what do you think? What has happened? Did it gain electron? It lost electron. Sorry.
I made a mistake.
Okay, you understand it now, right? Yeah. Okay, fine. That I have not received yours, by the way. Okay, so here we are going to have oxidation, or it is going to be the anode. It is going to be reduction, or it is going to be cathode. So oxidation anode, because Cu2 to Cu2 positive, and it is going to be reduction or cathode. Okay, so here we are going to make a nickel to nickel 2 positive with a bridge. And Ag positive to Ag. You don't need to worry about the coefficients here. Okay, here we have copper to copper 2 positive, and then here we are having Ag positive to Ag. Okay, Zed, I received that. That is fine. Correct. I received now. Okay, fine. Okay. So that's it for today. Okay, guys. And